So we have two formulas we're going to look at today. We're going to look at our dot product formula, and we're going to look at our magnitude formula again. Alright, so if we look at our dot product formula, and we're given a vector u of u1, u2, and a vector v of v1, v2, if we're taking the dot product of them, we're multiplying our corresponding parts and then adding them together. So u1, v1 plus u2, v2. It's pretty straightforward. For the magnitude, this is just a different representation of the same magnitude formula that we've been using. So u times u equals the magnitude squared, or the magnitude equals the square root of u times u. Okay. So if I look at example 1a and I go to find my dot product, I'm given a vector u of 4, 5, and a vector v of 2, 3. Okay, my dot product formula tells me that I take u1 times v1 plus u2 times v2. So I'm going to let my first term be u1, u2, and my second vector be v1, v2. So if I plug in my u1 and v1, my u1 is 4, my v1 is 2, my u2 is 5, and my v2 is 3. Alright, 4 times 2 gives me 8, 5 times 3 gives me 15, and 8 plus 15 gives me 23. So my dot product would be 23. Makes sense? Okay. If I look at 1b, I'm going to do the same thing. So u is equal to 2, negative 1. V is equal to 1, 2. Okay, so if I label my u1, u2, v1, v2, and then plug that into my formula, I take my u1 first, so 2, times my v1, which is 1, plus my u2, which is negative 1, times my v2, which is 2. Okay, 2 times 1 gives me 2. Negative 1 times 2 gives me negative 2. 2 plus negative 2 gives me 0. So So my dot product of u and v is 0. Told you it was mind-blowing stuff today. I warned you. Alright, if I look at vector 0, 3 and vector 4, negative 2. And I go to find the dot product. My u1 is 0, and my v1 is 4. My u2 is 3, and my v2 is negative 2. Well, 0 times 4 is 0. 3 times negative 2 is negative 6. 0 plus negative 6 is negative 6. Okay, and if we look at dot products times other vectors, so we have u dot v times w, where u is negative 1, v is negative 1, 3, v is 2, negative 4, w is 1, negative 2. Okay, so I'm going to label them u1, u2, v1, v2, w1, w2. So I'm going to start by finding my dot product u times v. So to find my dot product of u times v means I take negative 1, which is u1, times 2, v2, v1, plus u2, which is 3, times v2, which is negative 4. Negative 1 times 2 gives me negative 2, 3 times negative 4 gives me negative 12, and negative 2 plus negative 12 gives me negative 14. The second part of that was taking that times w. So if I fill in w, which is 1, negative 2, then I just distribute my negative 14. So negative 14 times 1 is negative 14. Negative 14 times negative 2 is positive 28. Your dot product just ends up being a constant that you multiply through your next vector. Okay, there we got that. Alright, if I look at 2b, I've got u equals negative 1, 3, v equals 2, negative 4, w equals 1, negative 2. So the same numbers from our last problem. Except this time I'm going to find u dot 2v. Okay, well, since I'm only using u and v, I obviously don't even need w. I'm going to label this u1, u2, v1, v2. Before I can find my dot product, I first have to figure out 2v. So to figure out 2v, that actually means 2 times my v vector, which is 2, negative 4. So then I end up distributing my 2, and I get the vector 4, negative 8. So 4 and negative 8 become my new v1, v2. So then if I want to find my dot product of u and 2v, Then I take my u1, which is negative 1, times my new v1, which is 4, because we're using my new vector, times u2, which is 3, times my new v2, which is negative 8. Okay, well, negative 1 times 4 is negative 4. 3 times negative 8 is negative 24. And negative 4 plus negative 24 is negative 28. Okay, so that's all dot product. Second formula that we looked at was our magnitude formula. So if I'm given the dot product of u times u equals 5, and it asks me to find my magnitude, well, one of my magnitude formulas was u dot u equals the magnitude of u squared. That's one of the ones we wrote down at the beginning of class today. So if I substitute in 5 for u dot u, then I end up with 5 equals the magnitude of u squared. So if I want to get rid of this squared so I can get my magnitude by itself, I take the square root. I did have 2 u's, u dot u equals 5, so that's why I plugged that in. The square root and squared cancel, so my magnitude of u equals the square root of 5. Okay, so if I do the same thing for u dot u equals 7, I want to find my magnitude of u. Okay, so we use the same formula. U dot u equals the magnitude of u squared. I plug in 7 for u dot u because I know that u dot u equals 7. I get 7 equals the magnitude of u squared. Take the square root, so my squared and square root cancel. I end up with the magnitude of u equals the square root of 7. Okay, so also pretty straightforward. The last thing that we're going to look at is how to find the angle between two vectors. Alright, so I'm given u and v of 4, 3, and 3, 5, and I want to find the angles between them. My angle between them formula says the cosine of theta equals u dot v divided by the magnitude of u times the magnitude of v. Okay. So first thing I'm going to find is my dot product. Okay, Okay, so U1, U2, V1, V2. Okay, so to find my dot product, I take my U1, which is 4, times my V1, which is 3, plus my U2, which is 3, times my V2, which is 5. Okay, so 4 times 3 is 12. 3 times 5 is 15. 12 plus 15 gives me 27. So I know that U dot V is going to equal 27. Okay, the next thing that I need to find then is my magnitude of U. The magnitude of U equals the square root of U1 plus U2. Okay, that's the formula that we learned yesterday. So if U1 is, or U1 squared, sorry, plus U2 squared. So U1 squared gives me 4 squared, U2 squared gives me 3 squared. Well, 4 squared is 16, 3 squared is 9, 16 plus 9 is 25, square root of 25 equals 5. So I know my magnitude of U is 5. Last thing that I have to find is my magnitude of V. So I use the formula V1 squared plus V2 squared. Well, V1 is 3, so 3 squared. V2 is 5, so 5 squared. Three squared is 9. 5 squared is 25. 9 plus 25 is 34. So my magnitude of V is the square root of 34. So if I plug all of that in to my cosine of theta formula, I figured out that U dot V was 27, so that's what's going to go on top of my fraction. And then my magnitude of U was 5 times my magnitude of V, which is square root of 34. Now that I know that, I get rid of a cosine how? How do I get rid of this cosine? So I take my inverse cosine, so cosine of -1. So you need to, I want everybody to plug this in on their calculators just to make sure that we get the same number. So make sure your calculator is in degree mode, that's the first thing. And then you need to plug that in exactly as it looks. Inverse cosine of 27 divided by 5 square root 34. Make sure your calculator is in degree mode though, that's the main thing. The heck? That's what I got too. That's not what you're supposed to get. You're supposed to get 22. Now, let's see. Oh, you have to put the 5 square root of 34 in parentheses. You have to put the 5 square root of 34 in parentheses. If you do that, then you should get an answer. that work then? Did we do that? Okay. Mark, did you get it? Okay. Alright, so if you put that in parentheses, then you end up with theta equals 22.166 degrees. Did you get it? Okay. So I guess we have to be careful how we enter that in our calculators. I didn't know we'd do that. Alright, so let's do one more like that, and then you'll start your assignment. So U is 30, V is 16. We want to find the angles in between them. Okay, so my cosine formula is cosine of theta equals U dot V divided by magnitude of U, magnitude of V. Okay, so if I first start by finding my dot product of U dot V, take my U1, which is 3, times my V1, which is 1, plus my U2, which is 0, times my V2, which is 6. 3 times 1 is 3, 0 times 6 is 0, and 3 plus 0 is 3. So I know my dot product is 3. To find my magnitude of U, magnitude of U is the square root of U1 squared plus U2 squared. Okay, so my U1 is 3, so 3 squared, plus my U2, which is 0, so 0 squared. 3 squared is 9, 0 squared is 0. 9 plus 0 is 9. Square root of 9 is 3. So I also know that my magnitude of U is 3. Okay, lastly I need to find my magnitude of V, which equals the square root of V1 squared plus V2 squared. Okay, so my V1 is 1, so 1 squared, plus my V2 is 6, so 6 squared. 1 squared is 1, 6 squared is 36. 1 plus 36 is 37. Okay, so my magnitude of V is square root of 37. Alright, so plugging that on to my cosine formula, I get the cosine of theta equals U dot V, which we figured out was 3, divided by my magnitude of U, which is also 3, times my magnitude of V, which was square root of 37. Then to get rid of a cosine, we do what? Inverse. So inverse cosine. Inverse cosine. Make sure you put your denominator in parentheses. So inverse cosine of 3 divided by 3 square root of 37. Okay. That one has to come out. I don't know. and then start your parentheses there. There you go. Alright, so we should have got theta equals 80.538 degrees. Okay. Alright, so you guys are going to start your assignment today. We're going to keep working on it tomorrow. It is page 465, 7 through 44.